Airplanes aren't like cars that rely on headlights for illumination. Instead, pilots depend on a combination of specialized cockpit instruments, built-in aircraft lighting systems, and air traffic control procedures to fly safely at night. Here's how it works. Instrumentation and Avionics. Modern aircraft are equipped with sophisticated flight instruments. Pilots rely on gauges, digital displays, and systems like the attitude indicator, altimeter, airspeed indicator, and heading indicator. These instruments provide real-time information about the airplane's orientation, altitude, speed, and direction regardless of external light conditions. In instrument flight rules or IFR conditions, pilots follow a flight plan using these instruments rather than external visual cues. Cockpit lighting. The cockpit itself is designed for low-light conditions. Pilots use adjustable task lighting and backlit displays so they can read their instruments clearly, even when flying in darkness. The lighting is carefully controlled to avoid glare and help preserve the natural dark-adapted vision of the pilots. Exterior aircraft lights. Airplanes have installed external lights such as navigation lights, red on the left wing and green on the right wing, strobe or anti-collision lights, landing lights, and taxi lights. While landing or taking off, the landing and taxi lights help illuminate the runway and taxiways. Navigation and strobe lights help other pilots and air traffic controllers see and track the aircraft's position in the sky and in the airport vicinity. Air traffic control and navigation aids. Pilots are guided by air traffic control or ATC and use navigational aids such as ground-based radio beacons, very high-frequency omnidirectional range or VRUR, and more recently, systems like Global Positioning System or GPS to ensure they fly on the correct path. This system of radio navigation and radar ensures that even in darkness or poor visibility, the aircraft stays on course and maintains a safe distance from other traffic. Night vision and training. Pilots undergo extensive training to handle night flights. Their eyes adapt to low light conditions, a process called dark adaptation, which enables them to see better in a dark cockpit and faint exterior lights. Additionally, many pilots are trained in instrument flying techniques, which means they can navigate effectively without relying solely on their vision outside the cockpit. If you've ever flown as a passenger and stared into the darkness, you may wonder how pilots see at night. Well, today, you are going to get all the answers. We will take a detailed look at night flying, how the pilots see, and even discuss some of the hazards if you find yourself airborne in darkness. The truth is that pilots who fly at night will navigate using instruments instead of what they can see outside. This type of flying is conducted under instrument flight rules. Some ground features may be visible, but visual cues aren't normally as reliable in the darkness as in the daytime. Pilots use several techniques to see and navigate at night without relying extensively on outside visual features. Here's what you need to know. How do pilots see at night? The short answer, with great difficulty. While it's possible to pick up a few ground features, pilots will generally prefer to navigate using their instruments to get around the sky in darkness. How do they achieve this? Well, they use the following things within the cockpit to give them a great idea as to what is going on outside when it is dark. Lateral night navigation. While during the day pilots may opt to use prominent ground-based landmarks to work out where they are, at night, this isn't easily achievable. However, there are a few tools that the pilot can use to work out their position. VRUR. VRUR stands for Very High Frequency Omnidirectional Range. Yes, we know, it's a bit of a mouthful. This is a ground-based navigation aid that emits signals that can be picked up by a receiver on the aircraft. This beacon outputs 360 different lines or radials. All the pilot needs to do is lock onto a specific radial and follow it. The instrument will show whether the aircraft is to the left or right of the chosen radial. When flying overland, it is common practice for aircraft to hop from beacon to beacon until they reach their destination. NDB stands for non-directional beacon. It's a bit like a VRUR, except it doesn't have radials. Instead, it emits a circular non-directional beam, hence the name. The pilot will use an instrument called an automatic direction finder, or simply ADF, to interpret the signals. This simple instrument looks a little like a compass, but instead of pointing north, it will point towards the NDB. Pilots can work out where they are if they know your position relative to something else, such as an NDB. GPS. Like with your car, many aircraft have inbuilt satellite receivers that allow the pilot to visualize their location on a moving map. While navigating solely by reference to this instrument isn't recommended, it is a handy situational awareness tool that can give a great visual overview of the airplane's location. Altitude perception. Flying at night isn't just about where you are horizontal. It's vitally important that pilots ensure they have sufficient clearance from the ground too. Luckily, a handy instrument will tell them precisely how high they are above sea level. As long as they know how high the surrounding terrain is above sea level, they can work out their height above this terrain. The horizon. Whether flying at night or during the day, pilots need to see some kind of horizon. They use this to determine the airplane's attitude. At night, pilots will turn their gaze from outside to inside and use the artificial horizon. The artificial horizon is normally a simply globe split into two hemispheres. Using this instrument, the pilot can determine whether the aircraft is in a climb, a dive, or rolling. Avoiding weather. One thing that might be readily apparent during the day, but not so obvious at night, is bad weather. While thunderstorms can be quite visible when they are flashing and banging, they don't display either of these characteristics during certain stages. In the case of commercial aircraft, pilots will utilize a weather radar. Information regarding thunderclouds will be displayed on their navigational displays. They will do their utmost to fly around the most obvious areas of danger. Judging speed. Pilots need to keep a close eye on their speed. It can be really difficult to gauge how fast the aircraft is flying with reference to the ground at night. To counter this, pilots will make constant reference to an airspeed indicator. This instrument uses air pressure to gauge how fast the aircraft is flying. Because of reduced visual cues outside the aircraft, most pilots will opt to fly under instrument flight rules, relying on the internal instruments of the aircraft to help them navigate the skies in darkness. Visual flight is possible, but is challenging in comparison to its daytime counterpart. 4 hazards to be aware of while flying at night. Flying at night comes with its own brand of hazards, which are very different from during the day. Here are some things to be cautious of when getting airborne in the dark. Visual illusions. The human eye is much better suited to daylight conditions and is somewhat limited at night. Visual illusions can cause confusion and disorientation. The most common nighttime illusions in aviation include black hole effect. This is one to watch out for when making approaches to remote airfields. It can be difficult to judge altitude with no visual references aside from runway lights. Big airports have precision approach path indicators for entirely this reason. The lack of visual cues can lead pilots to lose any sense of depth perception. There is often the temptation to duck under the correct approach path, making the airplane lower than it should be. Distance illusion. Judging distance at night is very tricky. The human brain normally fills in the gaps and uses the surrounding topography between 2 points to gauge distance. This might not be visible at night, making it hard to tell how far the airplane is from a feature. Effects of autokinesis. Have you ever sat on a train stopped at a station and the train next to you moved? Did you briefly feel like you were moving? This principle is exactly the same with autokinesis. Moving lights at night can't trick your brain into thinking motion exists where there is none. Sometimes the lights themselves don't have to move. There have been reports of pilots taking evasive action to avoid stars. In fact, it was the aircraft's rolling giving the impression of an airborne collision risk. Moving vehicles on the highway and even moonlight on waves by coastal airfields can create disorienting sensations while flying. False horizons. Remember how we talked about the pilot using the artificial horizon to work out the airplane's attitude? To fly on instruments, you have to sometimes ignore what your brain is telling you if you peek at the outside world. During darkness, many different phenomena are more apparent that give the impression of the horizon. If a false horizon is used by the pilot as a point of reference, this can be a flight safety issue. Terrain. You see that big radio mast over there? Well, you might not at nighttime. You can't always rely on obstacles and high points being lit by anti-collision lights. So how do pilots see at night, and how do they avoid terrain? Easy, it's 3 words. Minimum, safe, altitude, also referred to as MSA. In a nutshell, pilots will review their route and carefully note the highest terrain along with it before adding a fudge factor, usually 500–1,000 feet. They can fly safely at night because there is 0 risk of hitting an obstacle or terrain if they stay above this altitude. Flying under visual flight rules means that you must see and be seen. This doesn't change when you are flying at night. While generally it is easier to spot other well-lit aircraft in darkness, it is still worth having your wits about you. Engine failure considerations. This is a big one. While engines don't often fail on aircraft, the chance of a successful outcome is somewhat reduced when flying at night. During the day, it is often possible to pick a field. whereas easily visible fields may be hard to come by at night. Don't fly over areas you know to be poor landing sites, especially at night. Plan your route to include easy-to-reach diversion airfields and absolutely avoid flying over inhospitable terrain.